Okay, these are chapter 5 notes, solving trigonometric equations. This is page 3. So now we're moving off of sine and cosine, and we're going to talk about tangent. A couple things we want to keep in mind. Period for tangent is like waiting for you guys to answer me. So the period for tangent is pi. So these values are going to repeat every pi instead of every 2 pi, like sine and cosine. Okay? And I'm not really crazy about this theta minus pi over 2 as the argument. That's going to force me to think a little harder than I want to. So I'm going to go back to that reference point we talked about before. I know that the tangent of pi over 4 is 1. And so that means that whatever theta minus pi over 2 is, it has to equal pi over 4. And so I can solve for theta here. I'm going to add pi over 2 to both sides. I get theta is pi over 4 plus pi over 2. We need to create a common denominator so that we can add those. So I got pi over 4 plus 2 pi over 4. That gives me 3 pi over 4. Now, I'm going to go back up to my problem statement. This wants all possible solutions. And so since the period for tangent is pi, I know that this value repeats every pi. So all possible solutions is going to look like this. All possible solutions. Theta equals 3 pi over 4 plus k pi. So we're going to add on pi, 1 pi, 2 pi, where k is an integer. And that's what the solutions to this look like. Okay. Now we're moving on to something a little different. We want to solve these trig equations in sine and cosine when we have to use a calculator. So exercise 7 and 8 are a review, a reminder. First thing you want to do is make sure that your calculator is set to radians. The one thing that I noticed in the first exam was rounding was a little off. So we're going to make sure we're not truncating. We're not just cutting after 4 places. We're going to round appropriately. And so on exercise 7, example 7 here, if I want to use a calculator to solve for sine theta equals 0.8, I know that means that inverse sine of 0.8 is going to equal theta. When I plug in inverse sine of 0.8, I get 0.92729. If that is not what you got, make sure that your calculator is set to radians and not degrees. I want to round correctly to 4 places. There are my 4 places. That means I look at the 5th place and decide if it's closer to 0.9272 or 0.9273. And since that 9 is above 5, we are going to round this up. And our theta is approximately 0.9273. You notice I use the squiggly equal here. Anytime I'm rounding a decimal, it's an approximate. It doesn't really matter to me if you put equal or approximately equal. Just know that that squiggly equal is better. Okay. So example 8, using the calculator to solve for secant theta equals -4. Again, I don't have a secant button on the calculator, so I'm going to rewrite this as 1 over cosine theta equals -4, and I can write this -4 over 1, just to remind myself that if I've got this ratio, it's okay for me to flip both sides. And so if the cosine of theta equals -1/4, that means the inverse cosine of -1/4 equals theta. Our inverse cosine Once we plug that into the calculator, we get 1.82347. Again, I want to round to 4 places. I get 1.8235. And that's it for page 3.